First, let's figure out the mechanics of the sensor and the way it works. I've already demonstrated here that the photoresistor plays the central part. I want to mention that the photoresistor is different from a regular resistor in the way that the former changes its resistance depending on the amount of light that it is exposed to. There is one more resistor in the circuit and together they make up a voltage divider. Let's look at the diagram that we have in front of our eyes. It features a voltage divider. It comprises resistors 1 and 2, but between them the voltage is output somewhere else. In our case, it is output to the Arduino analog input. Let me remind you that we have Ohm's law for a circuit section, which states that the current intensity is directly proportional to the voltage. In this section and inversely proportional to the resistance, from this formula we can deduce the following relation. If we look at it attentively, we shall see that this Vout voltage depends on the relation of R1 and R2 resistance. Here we have a photoresistor installed in place of the R2 resistor, and its resistance changes according to the amount of light which falls upon it. As a result, the voltage on this output will be changing within the 0 to 5V range. Consequently, this voltage can be counted on the Arduino analog input. Now, let's make a variation of this experiment. Let's substitute the photoresistor in our diagram with a thermistor. Thermistor is also a resistor which changes its resistance, but these changes depend on the outside temperature. I am turning off the power. And I strongly recommend that you do the same when you are changing the diagram. Now I shall remove the resistor and insert a thermistor in its place. I am reconnecting the USB cable and starting the port monitor. We can see some numbers again. Now they are different from the numbers we saw when we had the light sensor working. This is because we have a different voltage divider now, and the output voltage is different. I can now change the temperature of the thermistor with the warmth of my fingers. We can see how the value falls and stops at 375. This is because I cannot warm up my fingers to a higher temperature than that. However, I can take a lighter and heat up the thermistor even more. The value continues to fall down to 130. Alright, now we are going to conduct another experiment. I have removed the thermistor from the diagram, as well as the 10 kiloohm resistor, and substituted them with this pot. Its full name is, in fact, a potentiometer. What is this thing? In a nutshell, it's a voltage divider coming in one package. If we look at the picture, we will see that inside it there is a conductor divided into two sections, whose length can change depending on the degree of the rotation of the knob. This means that I can set them like this or like that. As a result, resistance in each of these sections will also change. In other words, one half of the section is R1 while the other one is R2. The same thing happens with the voltage divider. I have reconnected the board to the computer and opened the port monitor. We can see 0 value here. I will now start to rotate the knob of the potentiometer and we shall see that the values are changing continuously up to 1023. This example has shown us the range of all possible values that we can have, because a potentiometer allows measuring the voltage in the range from 0 to 5V to which it is connected. In the course of these experiments, we have discovered that by changing the resistance at the analog input inside the 0 to 5V range, We can count out the values from 0 to 1023 in the controller, or 1024 different values in total. Let me mention that I have uploaded the program to the controller only once at the very beginning, and then it was outputting data from different sensors without any changes being implemented. This is an important thing to remember. The controller is absolutely unaware of the devices that are connected to it. All that it knows is what the voltage at its analog input is. How it measures the voltage and how one works with this in a program we shall examine later.